Hello again. In this video, I'm going to go over a homework problem from 5.1. And so in this problem, it says use the figures to calculate the left and right Riemann sums for f on the given interval and the given value of n. And so f of x here is x plus 5 on the closed interval from 2 to 7, and n is equal to 5. Okay, so let's calculate the left Riemann sum first. Okay, so to calculate the left Riemann sum on the closed interval from 2 to 7 with n equal to 5. Now remember, n is the number of rectangles that we're going to create for the Riemann sum. Okay, so the first thing we need to calculate is the width of each of those rectangles, which is delta x, and that's always b minus a over n. And of course, a is equal to 2, and b is equal to 7. Okay, so 7 minus 2 over 5, because n is 5. And so that would mean delta x would have to be 1, so the width of each rectangle would have to be 1. Okay, so just let's look at the picture of this. We're starting at 2. Each rectangle has a width of 1. So the first rectangle would go from 2 to 3. Okay, now we have to determine the height of that rectangle. And the way we're determining it is we're doing a left Riemann sum. And so we're going to pick the left endpoint in that interval, which is 2, and we're going to use that to determine the height of the rectangle on this interval. Okay, so at 2, this would be the height of the rectangle right there. Okay, so we're going to calculate the y value when x is 2. So in other words, f of 2. And that'll be the height of this rectangle. Okay, and so f of 2 looks to be 7. And then we're going to multiply that by the width of the rectangle, which is 1. So times 1. And that will give us the area of this first rectangle. Okay, so this is going to be our left Riemann sum. Okay, and then we're just going to keep doing this for each rectangle. So for the second rectangle, the width of that rectangle obviously is 1. Then we're going to go to the left endpoint of this interval, which is 3, and determine the height at that x value, which is the y value of the function at that x value at x equals 3. So it's going to be f of 3 times 1, right? The width of this little rectangle. So you just keep doing this for all 5 rectangles. The next one's going to have a width of 1, but the height's going to be f of 4. So that's the height of this rectangle, because that's the left endpoint, right? 4. So you plug 4 into the function, and you get f of 4 for the y value, and that's the height of the rectangle, times the width, which is 1. Okay, and then we're going to do this for the next one. For this interval, the left endpoint is 5, so we need to find f of 5 to get the height of that rectangle. And then times 1 to get times the width, which is 1. And then the last one would be this interval here. The left endpoint is 6. And so we need f of 6 to get the height of that rectangle. Okay, so f of 6 would be the height of this rectangle times 1, which is the width. Okay, and so that's going to be our left Riemann sum. So I'm just going to go through and calculate all of these. F of 2 is 7. So the first rectangle has an area of 7. F of 3 is 8. F of 4 is 9. And f of 5 is 10. And f of 6 is 11. Okay, and so those are the widths of these 5 different rectangles. I'm sorry, the areas of these 5 different rectangles. And then we're just going to add them up, and we get, what, 15, 24, 34, 45. And so that's our left Riemann sum. Okay, so that's part A. And then part B, the right Riemann sum. We're going to do this again, but this time we're going to pick the right endpoint to determine the height of the rectangle in the interval. Okay, so for example, the first interval goes from 2 to 3. Okay, but on that interval from 2 to 3, we're going to pick the right endpoint now because we're doing a right Riemann sum. And we're going to use that to determine the height of the rectangle for the Riemann sum. Okay, so actually it's going to be right here. Oops, let me draw that a little bit better. Okay, and so this is the height of the rectangle right there. So that's our rectangle. Okay, so it has a height of f of 3 and a width of 1. So there's the area of the first rectangle. And then you just keep doing this. The next one, the right endpoint would be 4. So the height of that rectangle is f of 4 times the width, which is 1. Of course, it would look like this. Okay, and then this one, the right endpoint is 5. So the height would be f of 5, which is right there, times the width, which is 1, and so on and so on. This one, you would use 6 for that because that's the right endpoint. And so f of 6 would be right there, times the width, which is 1. And then finally, when you get to the last rectangle, the right endpoint here is 7. So f of 7 gives you the height of that rectangle. And then times its width, which is 1. Okay, and so let's just find the areas of each of these and then add them up. Okay, so f of 3 is 8, f of 4 is 9, f of 5 is 10, f of 6 is 11, and then f of 7 would be 12. And each of those are multiplied by 1 because that's the width of each of the rectangles. Okay, and so we just add these up and we'll get the right Riemann sum. So it's 17, 27, 38, 50. Okay, so that's your right Riemann sum. Okay, so that's it. We're done with part A and part B. I just want to mention one other thing before we're done. Please take note that the more rectangles that you have, so if we increase the number of rectangles here to say 10 or 20 or whatever, the more rectangles that I have, the more accurate the Riemann sum is as to the approximate area that is trapped between the function and the x-axis between 2 and 7. So the more rectangles, the better the approximation for the Riemann sum. And what's going to happen is both of these Riemann sums, the left Riemann sum and the right Riemann sum, are both going to converge towards some number that's between 45 and 50. And whatever number they start converging towards, as n goes to infinity, that's the exact net area trapped between the function and the x-axis between 2 and 7. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.